All right, everyone, we're back. We're going to wrap up the consumer behavior section with a numerical example. There's only a couple slides in this part. We're going to work on this table for a little bit. So to start with, if you're taking notes along the way here, you should jot down these two columns. It says pizza, and it has a series of numbers under it. And then there's one that says Pepsi and has a series of numbers under it. So you can pause the video, jot those down, and then we're going to go on and talk about what they mean and how to deal with them. So, what you have in the pizza column are marginal utility numbers from subsequent units of pizza. So basically, for a particular person, because these are numbers that describe someone's satisfaction or happiness or utility, as we're going to call it. Right? So these are basically marginal utility numbers for a particular person. Now, my marginal utility from subsequent slices of pizza could look different than yours, right? Because tastes are subjective. Some people like pizza more than others. That's all fine, right? So this just refers to one particular person. And so basically, whatever the units are, in economics we sometimes call them utils. That's what's described here in the text I put below it. Suppose that these are just utils or some generic measurement of utility. And so for a particular person, the first slice of pizza gives them 20 units of happiness, 20 utils. The second slice gives them 16, the third slice 12, the fourth slice 8. Right? So you can see diminishing marginal utility is at play here. Right? The first slice they love, the second one is really good, the third one is also yummy, the fourth one is still good, the fifth one, right, gives them 4, the sixth slice gives them 0. What does that mean? It means that they're indifferent. Like they eat the sixth slice, and sure, the pepperoni had a nice flavor, but when they're done, they feel a little uncomfortable and they're not really any better off than they were after 5 slices. And what does this mean if you eat slice 7, right? 1, 2, 3, 4, 5, 6, 7. You eat slice 7 and you get minus 4 units of happiness. What does that mean? It means that after you eat it, you feel worse off than you did before you ate it. Now, some of us probably have made that mistake at an all-you-can-eat buffet at some point. But at the point when we were eating it, we still thought it was good. It's only the after effects, right, that made us uncomfortable. So that's a little indigestion, right, or heartburn, and of course -8, -16. It just gets worse from there, right, if you continue eating. So that's what's going on. These are marginal utility numbers from pizza. Let's see if I can hit. Can I erase these? Come on, there we go. And the same thing for Pepsi. The first can of Pepsi gives me 9, or gives a particular person 9 units of happiness, right? Satisfaction, enjoyment, right? So we call them utils. 9 utils, then 8, and 7, 6, 5, 4. So a very steady decline in marginal utility, right, from drinking Pepsi. So that's what you have there. Marginal utility numbers for a particular person for 2 goods, pizza and Pepsi. Now, I give you a couple other pieces of information here. Suppose that pizza costs $2 a slice. So I'm going to make a note here. The price of pizza is $2 per slice. And Pepsi is $1 per can. So the price of Pepsi equals $1. And so we can figure out, so these marginal utility numbers, that's bang, right? That's marginal utility. That's like the Porsche. Gives me a lot of utility. But the question is, how much utility does it give me per dollar? Because the bottom line is that sometimes a can of Pepsi gives me more bang for my buck than buying a Porsche does. So, it gives me a lot of bang, right? A lot of marginal utility. It also costs a lot of bucks. So, what I really want to find, so if this is my marginal utility column, what I really want is marginal utility. Let's try it with a standard looking M, marginal utility per dollar. How do I get that? I take the marginal utility and I divide by the price. Can you tell that's supposed to be marginal utility divided by price? Let me try that one more time, a little bit neater. Oh, wait. Technology, watch this. There we go. Marginal utility divided by price. So the first slice of pizza gives me 20 utils, right? 20 units of happiness. But it cost me $2. So what's the bang for my buck? 10. Right? 10 units of happiness per dollar. I took this and I divided the 20 and I divided by the price and I got 10. 16. All right, so the second slice of pizza gives me 16 units of happiness, but it cost me $2. What's the bang for my buck? What's the margin utility per dollar? 8. All right, 16 divided by 2. What about the third slice? 12 divided by 2 gives me 6. The fourth slice, 8 divided by the price, that's 2, so that gives me 4 units of happiness per dollar. And so 1, 2, 3, 4. The fifth slice, 4 divided by 2, that's 2. 0 divided by 2, that's 0. We could do the negative ones, but are we going to purposefully eat pizza that makes us worse off? Probably not. And so you could keep going down there, but I'm not going to expect that we're going to buy those anyway. Now, what about Pepsi? This is the marginal utility column. And then next to it, we need marginal utility divided by price. Divided by price. Oh, there's a good one. All right. But in this case, the price is $1. So what's this column look like? It's the same, right? 9, 8, 7, 6, 5. But 9, what's 9 divided by 1? 9. What's 8 divided? You see where this is going, right? So we can just work off that same column. So now we have marginal utility, and then we have bang for your buck, marginal utility per dollar. So I'll give you one more thing to think about here. Suppose you have $10 to spend. So you have $10 in your pocket. You're going out with your friends. The only two things that you can consume at the place you go to is pizza and Pepsi. How do you maximize your utility? That's what we really want to know here. So, well, I have $10 in my pocket, and I see how do I, what gives me the most bang for my buck? Should I spend, what's the first thing I should buy? How do I maximize my utility? Do I buy a slice of pizza or do I buy a can of Pepsi? And so you could say, well, a slice of pizza gives me 20 units of happiness and a Pepsi only gives me 9. So I should buy the pizza. Well, wait, what am I looking at there? That's like our original hypothesis, right? That you'd get the thing that gives you the most bang. When in fact, we need to look at what gives you the most bang for your buck. So now, as it turns out, you're still going to get pizza, but the reasoning that you're going to buy a slice of pizza first is that the pizza gives you 10 units of happiness per dollar, right? Because it gives you 20 units of utility, and it's $2, so it's 10 units of utility per dollar, where the Pepsi only gives you 9. So the first thing that you would do is buy a slice of pizza. So I'm going to buy one slice of pizza. But how much does that cost me? Because remember, I only have $10 to spend. Whoa, where did that go? Come back. Only have $10 to spend, right? So now I've spent 2. So let's see, how do we keep track of this? We'll do a tally. Right there, I've spent 2. So that's a tally mark. So now, what am I going to buy next? Well, our theory says I buy the thing that gives me the highest margin utility per dollar. So which is that? My first can of Pepsi, which gives me 9, or my second slice of pizza, which gives me 16 in total, but 8 per dollar because it costs $2. Well, the next thing I should buy is a Pepsi, right? Because that gives me more bang for my buck than the pizza. So I'm going to spend $1 to buy a Pepsi. So now I have one pizza and one Pepsi. What should I buy next? Pizza or Pepsi? Which gives me the most bang for my buck? Well, it turns out they both give me 8 units of happiness per dollar. Right? So I could buy either one. As it turns out, I have $7 in my pocket, so ultimately I can get both of them, right? I'll buy a slice of pizza and a Pepsi, and that's another $3, right? So 1, 2, 3. So it looks like I spent $6 total. What are you going to do next? Pepsi or pizza? Well, the bang for my buck from a Pepsi is higher than from a pizza, so I'm going to buy a Pepsi. And now what? What's next? Where am I now? I have 3 Pepsis and 2 slices of pizza. What should I do next? Well, the bang for my buck from pizza and the bang for my buck from Pepsi are exactly the same. So I could get either one. Do I have any constraints here in terms of spending? I still have $3 left, so I could get either one, and then right after it I could buy the other, right? So ultimately I can afford both. But that's another $3. 1, 2, 3. that looks like $10. I spent all my money. So the best I can do, according to our theory, is that I would buy 4 Pepsis and 3 slices of pizza. Now, we can figure out my total utility from this. My total utility from eating 3 slices of pizza and 4 Pepsis is 20 plus 16 plus 12. And so what is that? 20, 36, 48, plus 9 plus 8 plus 7 plus 6. So where were we? 48, 57, 65, 72, 78. Total utility equals 78 units of happiness. 78 utils. Now here you can pause the video and challenge yourself and go back and see if there's any other combination of pizza and Pepsi that you can buy, at $2 a slice and $1 a can if you have $10 in your pocket. Try to find some other combination of pizza and Pepsi that will give you more than 78 total utils. Right? So basically what we found here is that you would get 3 slices of za, right, and 4 Pepsi, and that would give you 78 utils. So can you beat that? Can you do better than that by some other combination? I challenge you. Right? I don't think you'll find out that you can. The other way to think about that is, what if you look on the margin and say, all right, well, what if I changed it just a little bit? What if I gave up 1 slice of pizza? And what's the opportunity cost of a slice of pizza? Well, it's 2 Pepsis. Right? So if I gave up 1 slice of pizza, I could buy 2 Pepsis, but that 1 slice of pizza gives me 12 units of happiness. I'd give up 12 and I would gain 9. Is that going to make me better off? No. Right? What if I went the other way? What if I gave up 2 Pepsis in order to buy a slice of pizza? Those last two Pepsis gave me 6 plus 7. That's 13 units of happiness that I would be giving up in order to gain 1 slice of pizza, which would give me 8. Well, that's going to drive my total utility down as well. Right? So there is the bang for your buck, the margin utility per dollar in action. And remember the rule of equal margin utility per dollar spent that we talked about? Look at where your total utility is maximized. The bang for your buck from pizza is 6. The bang for your buck from Pepsi is also 6, right? 6 utils per dollar. So we are meeting the rule of equal margin utility per dollar. So there you go. That's step 1. I mean, that's actually a full example, but I want to change it up. Right? Let's do something else here because that will take us to our next important concept, and that is let's change a price. Right? What if there is a price change? What if there's a kind of happy hour on pizza? And so what if during happy hour pizza only costs $1? So if pizza only costs $1, so the price of pizza, the nominal price of pizza goes down, the price of Pepsi stays the same, right? So Pepsi stays at $1, pizza goes down to $1, right? So there's a decrease in the price there. All right, that's kind of a sloppy circle around there, isn't it? Let's go back and make it so it doesn't overlap. There we go. It's $1. Now, you still have $10. We'll keep the budget the same. You still have $10 to spend. What do you do with it? Well, where's your margin utility per dollar now? Since my price is only $1, then the margin utility per dollar is going to be this first column, right? Just like it was in the Pepsi. So let's do this example again. I'm doing it in this pinky purple kind of color. I'm going to say, all right, if pizza only costs $1, what should I buy first? I have $10 to spend. I want to maximize my utility. Should I buy a pizza or a Pepsi? Well, in this case, if they're each $1, I'm going to buy a pizza, right? Because 20 is greater than 9. What should I buy second, right? So now we should keep track of this somewhere else. Keep track of it over here. I've spent $1. Now, what do I buy next? My second slice of pizza or my first Pepsi? Well, 16 is greater than 9, right? So I'll buy another pizza. Spend another $1. What's the third thing I buy? Well, I'm going to buy another pizza because 12 is greater than the marginal utility from my first Pepsi, which is 9. Now what am I going to get next? Pretty thirsty at this point, right? So my fourth slice of pizza only gives me 8, but my first Pepsi, that gives me 9. So I'm going to buy a Pepsi. So now I'm at $4 spent. What am I going to buy next? A slice of pizza or a Pepsi? Well, either one, right? The marginal utility per dollar is the same. Turns out I can afford both, so ultimately I'm going to get both of them. There's 1, 2. What next? Well, another Pepsi, because 7 is greater than 4. And what next? Well, another Pepsi. What next? Another Pepsi. What next? Pizza or Pepsi? Well, this one, pizza, next slice of pizza gives me 4. My marginal Pepsi also gives me 4, so I can buy either one. In fact, why don't I just get both? That's actually a question. Why don't I just get both? Because I've already spent $9. I only have $1 left, right? So I've got to get either this slice of pizza or this Pepsi, but not both. I can't afford both. So that's where we are. We're going to have either 4 pizzas and 6 Pepsis, or 5 pizzas and 5 Pepsis, one way or the other. Now, do we achieve the rule of equal margin utility per dollar spent? Not quite, right? Because I'm either going to be at 4 and 5, right? Or 8 and 4. So they're not exactly equal. In a perfectly continuous world, you could buy half a slice of pizza and half a can of Pepsi, and your bang for your buck would be exactly equal for both of them, right? In a perfect world, I could take my last dollar and I'd split it, and I was buying half a slice of pizza and a half a Pepsi, and then my bang for my buck from this, both of them would be exactly equal. We don't live in a continuous world, right? You have sometimes our consumption is lumpy, and so you have to. There are trade-offs. You can't go to the pizza shop and ask them for half a slice and see how that works out for you, right? They're not going to sell you half a slice. So we're not exactly at the equal margin utility per dollar, but we're pretty close. Okay? And so in a lumpy world, that's why I try to say your bang for your buck from all the different things that you buy or the things you consume should be about the same. So there you go. We lowered the price of pizza. At the end of the day, we consumed more pizza and we consumed more Pepsi. And so that's what I want to talk about next. So if you have any questions about what we did so far, definitely follow up with me, right? And we'll shoot me an email and we can work through it. But I want to talk now about how a price change affects your consumer optimum. So remember, in our example, the price of pizza went from $2 to $1. But ultimately, our consumption of pizza went up and our consumption of Pepsi went up. And that's because there are 2 separate effects. So one of them is the substitution effect. The substitution effect says that consumers shift away from goods that are relatively more expensive and move towards things that are relatively cheaper. So the substitution effect says that consumers will substitute away from things that are relatively more expensive and toward things that are relatively cheaper. So what do we mean relatively? Well, it all has to do with opportunity cost. So we know that the price of pizza went from $2 to $1. What happened to the price of Pepsi? Well, in nominal terms, in actual dollars, it stayed the same, right? It used to be $1, now it was still $1. So in nominal terms, it stayed the same. But what happened to it in relative terms? This is where you have to think opportunity cost. So think opportunity cost, right, when you're thinking about the substitution effect. Initially, at the original prices, what was the opportunity cost of a slice of pizza? Well, it was how many Pepsis you gave up. And initially, how many Pepsis did you give up? You gave up 2. So the relative price of pizza initially was 2 Pepsis. After the price change, what happened to the opportunity cost of pizza? Well, it went down. Right now, you only give up 1 Pepsi every time you have a slice. So the relative price of pizza went down. And that's not a surprise. We saw the nominal price go from $2 to $1. But what happened to the relative price of Pepsi? We know the nominal price, right, the actual dollar price stayed the same. At first it was $1, Afterwards, it was $1. But the relative price changed. Because initially, how much did a Pepsi cost you? It cost you a half a slice of pizza, right? The opportunity cost of one Pepsi was a half a slice of pizza. After the happy hour price for pizza, once the price of pizza fell from $2 to $1, what happened to the opportunity cost of Pepsi? Well, now every time you drink a Pepsi, you give up how much pizza? A whole slice. So the opportunity cost of Pepsi went from a half a slice of pizza to a whole slice of pizza. So the relative price of Pepsi went up. I'm going to say that again. The relative price of Pepsi went up, even though the nominal price stayed the same. And that's because you have to think opportunity cost. That's why I put that note there. So the substitution effect says that a consumer who faced a decrease in the nominal price of pizza would consume more pizza because, hey, pizza's cheaper, and less Pepsi because in relative terms, hey, Pepsi is more expensive. So in our previous example, the substitution effect would say, let's say, eat more pizza and drink less Pepsi. Right, that you would substitute toward pizza, and away from Pepsi. That is the intuition of the substitution effect. Now, what about the income effect? So you have the substitution effect, and then you have the income effect. The income effect has to do with, are you relatively richer or relatively poor? Do you feel effectively richer or effectively poor? Well, if you have $10 in your pocket and you were going out with your friends to a pizza shop where you can buy pizza for $2 and Pepsi for $1, right? There's a certain amount that you think you can consume. But if you went there and you still had $10 in your pocket, but everything costs $1, do you feel effectively richer or effectively poor? You're effectively richer, right? You still have just $10, but you can consume more stuff, right? Basically, the prices of the things you buy, or at least one thing you buy, went down, and so you can buy more of all the good stuff you like, all normal goods. So if the price of something you regularly buy goes down, you feel effectively richer, and you can buy more of all the good stuff you like. You can buy more of all normal goods. So even if your nominal income didn't change, if the price level of things you buy goes down, you feel effectively richer, you can buy more good stuff. On the other hand, if the price of something you buy goes up, well, then all of a sudden you feel effectively poor, and therefore you might buy less of all good things, right, of all normal goods. And so the real world example that might help you with this is the price of gas, right? Our demand for gasoline in the short run is fairly inelastic, right? For the most part, we drive to work, we drive to school, we run certain necessary errands. And if the price of gas goes up a lot, people will still buy gas. Right? They may conserve a little bit and buy a little bit less, but they'll still buy almost as much gas as they did before. So in the short run, our demand for gasoline tends to be fairly inelastic. Now, if the price of gas goes up a lot, how does that affect you? Do you feel richer or poorer? Let's say that your income hasn't changed. Your income and your wealth are the same, but when the price of gas goes to $4.50 a gallon, you feel effectively poorer, right? And so what happens to your consumption of other things that you like? What happens to, how many clothes or shoes you buy? What happens to your dining out budget, your eating out budget? What happens to vacations, right? Well, it's possible that you end up cutting back on some of those other things. Why? Because you feel effectively poor because the price of gas went up. On the other hand, when the price of gas fell to $2 a gallon, right, a lot of households felt effectively richer. And at the low price, did they buy more gas? Maybe, right? Maybe they did more joyrides, went on more road trips. But did they also buy more of other things? Did they eat out more? Did they go to more concerts? Did they get more clothes? Did they do more home improvements? Whatever it is, whatever the normal goods are that you like to consume, when the price of gas goes down, you might find that you consume more of them. So the income effect, because the price of pizza went down, would suggest eat more pizza, and, well, I guess not eat, drink more Pepsi. So the income effect says have more of both. Of course, it works the other way too, right? If the price of pizza had gone up, then you'd feel effectively poor, and the income effect would say, whoa, you can't afford so much, right? Cut back on pizza and Pepsi. Cut back on all the good stuff you like. So that's what the two effects suggest. Now, these, sometimes I envision these as like little birdies that sit on your shoulder, sort of like the cartoons with the angel and the devil, right? Where they're giving you different advice. Here, the two effects sometimes give you different advice. Now, with regard to pizza, they both say eat more, right? The substitution effect says, hey, pizza is relatively cheaper, have more pizza. And the income effect says, hey, you're effectively richer, have more pizza. So both effects say you should eat more pizza. And if you look up here, after the price change, did you eat more pizza? Yes, you had one or two more slices of pizza. So both of them suggest you should eat more pizza. In our example, you did eat, consume more pizza. That all makes sense. Now, what about with regard to Pepsi? Well, the substitution effect says, hey, stay away from Pepsi, right? It says Pepsi is relatively more expensive. You should substitute away from that, right? Less Pepsi, spend that money on pizza. The income effect, though, says, hey, life is good. You're effectively richer. Have more of all the good stuff. Have more Pepsi. So they're giving you opposite advice. Right? What that means is they're pushing in opposite directions. Both effects are real. Both effects are happening, but they're pushing you in opposite directions. And so in some cases, they could be exactly the same magnitude or size, and they would sort of cancel out, and you'd have about the same amount of Pepsi. Or one could be stronger than the other. So you tell me, in our example, which effect was stronger, the substitution effect or the income effect? In our example, after the price of pizza went down, we consumed more Pepsi, either one or two more Pepsis, which means which effect overpowered the other? Well, in our example, the income effect was stronger. That doesn't have to be the case. It could be that in some cases, a person is facing, there's a change in the price of something they normally buy. The substitution effect could overpower the income effect. That's also a possibility. All we know is that in our example, we know the income effect was greater because, in fact, we did have more Pepsi. So there you go. Just be familiar with these two general concepts, the substitution effect and the income effect. And then I just tried to use the example we had worked here as a way to see those at play. All right, one last question for you. And this is where you can use the power of economics and the topics from this lesson to answer it. So, why are newspaper vending machines and candy vending machines made differently? Now, all right, newspaper vending machines, I know that is becoming a thing of the past, right? But maybe you've still seen them out there somewhere. You know what they are. So the number of newspaper vending machines, for people who have seen them, they're simple metal boxes, right, with a glass window and the newspaper inside. You put in your change, you put in the price of the paper. It's a very, very simple, cheap kind of vending machine. You put in the money, you unlock it, it opens the door, and then you reach in and grab a paper. Is there anything preventing you from grabbing 3 or 4 or 10 papers that are stacked up in there? No, they just trust you to buy you paid for one paper, it unlocked the door, you grab your paper, it closes back up. How do candy machines or soda machines work? The same way. You put in on campus, I think you put in $1.75, and then you open the door and grab the soda that you want. No, it doesn't work that way. You put in the money and then it gives you the one soda that you paid for. You don't just open the door and grab what you want. And why is that? Well, clearly it's because people who read newspapers are honest and people who drink soda or eat candy are dishonest, right? And they would cheat and they would take more than they paid for. Well, maybe. But a theory that says people who read newspapers are honest and people who eat candy and drink soda are dishonest, I don't know. I'm skeptical about that. What's your rationale? What's your support? Because is it possible that there are people out there somewhere that both read newspapers and drink Pepsi? I think that's possible. So how can you use the tools from this week's lesson to explain this? Well, I think it has a lot to do with marginal utility, right? What is the marginal utility of the first newspaper? Well, if you like to read the paper, right, and before everything was online, right, that was one important way to get the news. The marginal utility from the first paper is really, really high. Now, what's the marginal utility from the second copy of today's newspaper? Very, very low, right? Unless you're puppy training or something, right? The second newspaper has a very, very low value. So marginal utility kicks in really strong after one newspaper. But what about candy, right? Or soda? The first one is the best, right? Does diminishing marginal utility apply? Yeah, it probably does, right? The second candy bar, the second soda might not be as good as the first, but is it still good? Yes, right? Does the second candy bar have a much greater proportion of the utility of the first, marginal utility of the first one than the second newspaper does of the first newspaper? Yeah, I think so. All right, and beyond that, as pointed out here, newspapers are highly perishable. So, you could say, well, I'll just take 3 or 4 newspapers and save them, and then I'll use one. I'll read one today, I'll read a different one tomorrow, and then another one the next day. Well, reading yesterday's papers, kind of dumb, right? You already read it. It's the same thing. You get very little utility from reading it a second time. So we say newspapers are highly perishable because they don't really keep. They're not valuable the second day. Candy, though, candy's much more durable. I mean, it's still perishable, right? You don't stockpile it and use it in 5 or 10 years, but it does keep for a while, right? If you're real strict about sugar and you don't let your kids have a bunch of Halloween candy and you make them put it in the closet and you just divvy out a few pieces at a time, after a week they forget about it, and then you can hit the candy stash later on. There's a little life hack for you, right? That a month later, the candy is still good. So you can explain, all that to say, you can explain the difference in vending machines by thinking about a concept like marginal utility. And maybe that is a better explanation for why they're sold in different kinds of machines. So there you go. That is the second and final installment of the consumer choice theory section. Follow up if you have questions.